In this part of the tutorial, we'll create a basic setup for staged construction in Larsa 4D using construction and loading activities. In Larsa 4D, staged construction analysis is a 4D analysis that models changes to the structure over time. The construction sequence for our model will be in 4 parts. The first part of this construction sequence will construct half of the first span with a temporary support at the midspan, along with a temporary construction load. The second part will assemble the second half of the first span, add a second temporary load, and remove the temporary support. The third part of this construction sequence removes the temporary loads, which will then be repeated for the second span in the fourth part. To run a staged construction analysis, we'll first define the structure groups which group the parts of the structure that are assembled together. The first group we'll create will be for the left half of the first span. To begin, click the Group button above the Explorers to open the Structure Groups Explorer. Then open the Selection menu to unselect all objects by using Unselect Objects followed by Unselect All. Using the Selection mouse tool, drag a window to select the grounded spring for the left abutment and select the first 5 members on the girder. Once selected, click the Add Group button in the Structure Groups Explorer, which will add a new group for the selected objects. Now right-click and rename the group Span 1 Segment 1. We'll now do the same for the remaining 3 segments, including the pier in Span 1 Segment 2 and the right abutment in Span 2 Segment 2. As a shortcut, you can use the Shift key while holding F6 to unselect all geometry. Once finished, select all geometry from the Selection menu. Each condition of temporary or traveler construction loading must now be defined as a load case. We'll do this by creating 4 temporary loading conditions, which will be point loads at the midpoint of each girder segment. Each temporary load will be applied when the segment is first constructed and will then be removed when the entire span is complete. To identify the members that we'll place the temporary loads on, we'll again use Larsa's pointer mouse tool. Using the pointer, hover over the middle member in each segment. If we hold the Control key while hovering the mouse over the members, we can identify the member numbers, which should read 4, 9, 13, and 18. Now identify the 2 joints where we'll need to assign temporary supports, which are joints 10 and 19. Alternatively, you can also display member numbers in the Graphics window by opening the Graphics menu and choosing Show, or by using the keyboard shortcut N. In regard to the keyboard shortcut, N can be used to identify multiple objects in your Larsa 4D model. Hitting the N key once will display joint numbers, twice will display member numbers, and pressing it a third time will cycle to spring numbers. To turn off ID information, simply hit the N key a fourth time to remove the labeling. Now we'll refer back to the Load Cases Explorer, which can be opened by clicking the Load button above the Structures Group Explorer, and create 4 new load cases. We'll name these cases Temporary Load 1, Temporary Load 2, Temporary Load 3, and Temporary Load 4. Double-click the first load case for temporary loading and switch over to the Member Loads tab to pull up the spreadsheet. Add a new row and set the member name to 4, making sure that the direction is set to Global Z, and then change the magnitude at start to -100 kips. We'll also change its start position to 0.5, which is the middle of the member. Now click the second temporary load case and add the next member load. Set all the fields in the same way, but have the member name set as 9. We'll do the same for the remaining rows, but for the last 2 temporary load cases, have their member names set as 13 followed by 18. We can now close the spreadsheet, and the Load Cases Explorer will indicate the type of loading in each case. We can also verify that the loading is correct by opening the Graphics menu, selecting Show, and checking off the Input Loads option. Now select any of the 4 temporary loads in the Load Cases Explorer, and an arrow will appear in the Graphics View window indicating the location of the selected load case. Once finished, we'll turn off the Input Load option. At this point, we're now ready to set up the stages and steps within the staged construction. A construction step is a set of construction activities that occur simultaneously. A construction stage consists of all the construction steps that occur in a particular day of construction. In this tutorial, we'll place all construction steps in a single construction stage using the Construction Stages Explorer, which we can open by clicking the Stage button above the Explorers. Click the Add Stage button in the Explorer, and then double-click the new stage, which will open up the Stage Steps spreadsheet. To add more steps, we can either add new rows into the spreadsheet or click the Add Step button in the Construction Stages Explorer. For our bridge model, we're going to need a total of 8 steps. We can rename these steps through the Construction Stages Explorer by right-clicking each step individually or through the spreadsheet. In this example, we'll use the spreadsheet. Rename the steps as follows. First segment. Second segment. Remove temporary support 1. Remove temporary loads 1. Third segment. Fourth segment. Remove temporary supports 2. And remove temporary loads 2. Our next step is to apply construction activities. Have Larsa show two explorers at the same time by clicking the button above the explorers that resembles a square with a line going down it vertically. The top row of buttons above the explorer controls the left explorer, and the bottom row of buttons controls the right explorer. We'll set the right explorer to display the Structure Groups explorer by clicking the Group button in the bottom row above the two explorers. Now drag Span 1 Segment 1 from the Structure Groups explorer into the step named First Segment in Stage 1, Day 1 in the Construction Stages explorer. Now we'll take Span 1 Segment 2 and drag it into the step named Second Segment, and do the same for the third and fourth segments with Span 2 Segment 1 and Span 2 Segment 2. To apply self-weight and temporary loads, click on the bottommost Load button above the explorers to replace the Structure Groups explorer on the right with the Load Cases explorer. Take self-weight from the Load Cases explorer and drag it into the first, second, third, and fourth segments of our stage. In the staged construction analysis, self-weight is not applied unless it is explicitly included as an activity. As seen in this example, a self-weight load case should be applied in any step in which elements are constructed. Self-weight will be applied to all and only the newly constructed elements and not applied in other steps. Next, drag each temporary load case into the construction step it is applied in. To remove the temporary loading, we'll apply the same load cases again, but with the opposite sign which will cancel their effect. Drag temporary loads 1 and temporary loads 2 into the first Remove Temporary Load step, and temporary loads 3 and temporary loads 4 into the second. Notice the F equals 1 label next to each load case in the Construction Stages Explorer, which is a load factor. To remove the temporary loading, we'll change these load factors to -1. To do this, click Temporary Loads 1 in the Remove Temporary Loads 1 step, and at the bottom of the Construction Stages Explorer, it should now read Loading Factor. In the field below it, it will have the number +1, which will now change to -1, and click the check mark to apply the change. Now note the load factor labels in the Construction Stages Explorer reads -1 where the temporary loading is removed, and we'll do the same for the 3 other load removal cases. Now switch back over to a single Explorer view, which can be done by clicking the small square button with no split above the Explorers. In the next step, the addition and removal of the temporary supports will be defined. In the first segment step, we'll add a temporary support at joint 10, and in the Remove Temporary Support 1 step, we'll remove the support. The same will occur for joint 19 in the third segment and the Remove Temporary Support 2 steps. Right-click the first segment step in the Construction Stages Explorer and select Support and Hoist Activities. Add a new row and change the joint column of the row to 10. and set its translation Z to Fixed. Now click on the Remove Temporary Support 1 step to again select Support and Hoist Activities, add a new row, and change the joint column of the row to 10, but this time leave the Translation Z column as free. Do the same to fix Translation Z for joint 19 in the third segment step, and then free it in the Remove Temporary Supports 2 step. We can now close the spreadsheet, and the Construction Stages Explorer will indicate the type of loading in each case. We can also verify that the loading is correct by opening the Graphics menu, selecting Show, and checking off Input Loads. Now select any of the 4 temporary loads in the Construction Stages Explorer, and an arrow will appear in the Graphics View window indicating the location of the selected load case. Once finished, we'll turn off the Input Load option. We can now run the staged construction analysis, which will compute the state of the structure after each construction step. Under the Analysis menu, select Staged Construction Analysis, and then click Analyze. Once you save your project, the analysis will begin. After the analysis completes, close the Analysis window, and the Analysis Results Explorer will open automatically. For this analysis, the result cases can be found in the Construction Stages group. Inside this group, there will be a group for each construction stage, and inside that, the results for each construction step. To better visualize the results, let's turn on the Complete Rendering option within the Graphics menu. Now open the result groups and click the result case Stage 1 First Segment, and turn on the Graphical Deformation Diagrams. Set the scale factor to 128 and step through the construction sequence by clicking on each one to observe the analysis sequence. If preferred, you can also view the results numerically. As you step through the construction stage input or through staged construction results, you may find that the model starts to become gray or even disappear. This is because elements that have not yet been constructed in the selected construction step or result case are shown grayed, or in some results, and when complete rendering is turned on, hidden entirely. This may be inconvenient as you move between results and when revising model input, or the graphics may become out of sync with the result case you are viewing. When elements are grayed or hidden, a button appears in the Construction Stages Explorer called View Full Model to address this. Clicking this button will reset the graphical view to show all elements regardless of whether they have been constructed or not. This now concludes the last part of Larsa's Introductory Guide for Bridge Projects. If you'd like to learn more about Larsa 4D software or view the full catalog of Larsa 4D training materials, we welcome you to visit our website at www.larsa4d.com.